Okay, so good morning everyone. So today we are going to discuss about different types of network devices. So network devices, I hope you know, network devices is a physical or virtual devices, right, which help us to communicate in the internet or network, right? So without, so it may be I connected to another device, right? Indirectly, right? So except direct connections, right? So one-to-one connections. So if you don't know whether you are connected to the server or other devices, right? We cannot uh, measure how many devices are there in between you and the destination device, right? So network devices are basically interconnecting, right, the source and destination, right? Source and destination. There may be n number of network devices uh, which help us to transfer the data from the source to destination or sender to receiver. So in this video, we'll talk about the basic types of network devices, right? It should be used in computer networks, right? So the basic or simple network is a local area network, which we need to cover more distance than the media can handle effectively, right? So you can connect a number of stations uh, together to form a network, local area network, for efficient data delivery or data frame delivery and management of the network, right? Right. So the common devices used as network devices are repeaters, bridges, routers, gateways, hub, right? Network interface card, switch, modems, access points, right? So you can come across any one of the uh, network devices in your day-to-day life, right? Day-to-day life. So we'll discuss what are the functions of all those devices, right? So the connecting devices, right? The common connecting devices or network devices used in computer networks are repeaters, hubs, bridges, routers, right, and switches. There are two types of switches, two layer, second layer, two layer switches, or what do you call three layer switches, right? So repeaters, hubs, right? Layer one operates on layer one of the internet model. Layer one means physical layer. Bridges are two layer switches operates on first two layers. That means they will operate on both physical layer as well as on data link. Routers and three layer switches will operate on three layers, which means that operate on network layer, right? So here is a simple diagram which relates the uh, layer to the networking devices, right? Networking devices, the physical layer, repeaters and hubs, data link layer, bridges and two layer switches, network layer, router and three layer switches. But most of the switches are operating on the second layer, data link layer. So first we'll talk about repeaters. Repeaters operate on the layer one, right? Which means the physical layer, right? The functionality of repeaters is to connect two segments of the same layer, right? So left. So if you look at the diagram, see left side on left hand side and right hand side of the repeater, there are two types of different, sorry, same lane, right? The repeater will regenerate the original signal, right? It doesn't amplify, right? It doesn't amplify. It will regenerate the original signal, whatever transmitted from the source, right? It will regenerate the original signal because you know signal strength will degrade, right, as the distance goes, right? As the distance travels, the distance signal strength will reduce, right? Decreases. So the functionality of repeater is to regenerate the original signal, right? Original signal. So at the source, what is the signal power? right? Uh, 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 Power, area, right? Strength, everything will be regenerated at the end of the repeater. So even in your cable TV transmission, you can see for every 100 or 200 meters, you can see a block box will be there, right, between the cables. So it is a repeater. It's nothing but a repeater to regenerate the signal, right? So the basic functionality of repeater is to regenerate the signal, right? So it will solve the issue of attenuation or signal strength loss, right? So it receives the signal before it is too weak or corrupted and regenerates the original pattern. It will not amplify, it will not create a copy, right? It will receive the signal and regenerate the original form, right? And the second thing is hubs, right? Hubs, it's a multi-port repeater. It's also called as a multi-port repeater. So it connects stations in a physical star topology. See, you look at the diagram, it will connect all the devices in a star topology, right? So what it will do is it will receive the signal at one port, right? Say for example, it receives the data at one port means it will simply broadcast to all the remaining ports. Say for example, here we have 4 ports, right? So for all the 4 ports are connected to different devices, right? So at port 1, it has received the data, right? It will broadcast the data to all the remaining 3 ports, right? It will broadcast the data to all the remaining ports through which all the devices are connected. Whatever the data is received at the port 1, it will be simply broadcasted to all the remaining ports, right? Bridges operate in both physical and data link layer, right? Bridges operates in physical layer as well as in data link layer, and it is used to connect or divide two smaller segments or two different networks or to segregate two LANs. We can use bridges, same like the physical concrete bridges, right? So concrete bridges are used to connect two end of the roads, right? Two end of the roads. Similarly, here the network bridges are also used to connect two LANs, right? It could be a same type of LAN or different types of LAN. Uh, it doesn't matter. Bridges are used to connect, right, two LANs or to separate two LANs, right? So it will check the address of the frame and it will only forward to the segment to the other part of the other end of the bridge if it is intended for the network, right, or LAN. So this is the simple illustration of bridges. See, left hand side we have one network and right hand side we have one more network, right? So both the LANs are connected through a bridge, right? So it will check the datagram received at port 1, right? Port 1 or one end of the bridge. If the data frame is intended for LAN 2, then it will allow the packet to transfer to the other end of the bridge. Otherwise, it will not forward the packet to the other end of the. So if it is for local transmission, it doesn't allow the packet to penetrate through it. That is the functionality of bridges, right? So this is the illustration of bridge. So if it is intended for local within the network, right, it doesn't allow the packet to pass through the bridge, right? Whereas if the packet is intended for the other network, right, other network, then it will allow the packet to pass through the bridge, right? So there are different types of bridges, right? Transparent bridges, learning bridges. So initially we don't know anything about uh, the the number of devices connected and at which port the network 1 is connected and which port network 2 is connected. So originally we don't know anything about the address and port numbers, right? So it will learn from the transmissions, right? So initially, A started transmitting the data at port 1. So which means now the bridge will understand that port device A is connected at port number 1, right? Similarly, whenever the other devices also started transmitting the data, the bridge will store its details, address and port numbers at which the particular device is connected, right? So after later, if you want to transfer the data, it will check from the table and accordingly forward the data frames, right? And then spanning tree, redundant bridges, right? Redundant bridges means the number of bridges may be installed to provide reliability, right? So instead of uh, uh, sticking with a single bridge, your networks may have multiple bridges, right? To provide reliability between different lands, right, or different networks, right? And to prevent infinite looping of packets between bridges, a spanning tree algorithm will be used, right? So spanning tree algorithm will be used to prevent infinite looping. So if you don't use any algorithms, the packet may be uh, 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 continuously being transmitted between the networks, right? And then source routing. See, center of a packet defines bridges and routers, what route it should take to reach the destination. All right. So the complete path of bridge IDs and destination address is defined within the that is called source routing. So the source device will define the complete path, what number of bridges. So each bridge will have a ID and router will also have a ID, right? The source will define the number of bridges, right? It has to cross through with the bridge ID and the router ID, right? Uh, um, so this method is called as source routing, right? And this is particularly used with the tokens in topologies, right? So issues with the bridges, see, uh, frame format. If there are differences in frame structure, right? So this used to connect to two LANs, right? So if LAN 1 and LAN 2 are using different frame structure, then it is an issue, right, in connecting different LANs. And payload size. If you are using different payload size, data rates, right, and the address bit order is also differing in, then it will be a difficult process to connect two LANs using bridges, right? And the next device is two-layer switch, right? Two-layer switch performs at the physical layer and data link layer, right? So the purpose of the switch is to connect one-to-one devices, right? One source and one device. So same like our electrical switches, right? So if you want to switch on the fan or light, right? You can go to the you have to reach to the switchboard and turn on the particular switch to uh, uh, turn on the fan or light. Right? Similarly, the switch will provide one-to-one connection or dedicated connection between the source and destinations. Right? So backbone networks it allows several LANs to be connected, and it's like a uh, backup, right? No station is directly connected to the backbone, right? Stations are part of a LAN, and backbone is a LAN itself, right? So backbone is a LAN itself. So bus backbone, right? So topology or the local area network will act as a LAN itself, right? So topology is a bus here, right? And the used transmission range is 10 base 5 or 10 base 2, right? And it is used to connect two different buildings or two different uh, networks or flows, right, within a single building. And star backbone. It will implement the star topology, but the backbone is a star network itself, right? And acting different remote lands, right? Then you can make use of bridges and routers, right, to connect two different lands, right, uh, which are geographically located in different places. Virtual LANs, right? Local area network configured by software, not by physical wiring. You have a same concept of physical networks, but it will be implemented by software, not by the physical devices or physical wiring. That, right? Virtual LAN we'll discuss in a separate video, right? Uh, so router, the next important device, right, in the networks is router. See, router is a um third layer device, right, or a network layer device, right, that forwards the packet between the devices, right, between the devices, and it is also a very important component in computer networks, right. So suppose if you are searching for google.com in your web browser, then this request will be forwarded from your system to the Google server. You may not know how many intermediate devices are there from your device to the Google server, right? So you cannot reach uh, the Google server directly from your device, right? So the request will be uh, forwarded in multiple hops, right? Multiple hops, or in other words, there are multiple devices which will forward your request, right, from your device to Google server. So the important connecting device in this uh, scenario is router, right? Router. So the route basically router performs two major operations. One is forwarding and routing, right? So forwarding is the process of um, connecting the input port and the output port, right? So the router may have multiple ports, right? At one port, you may be connected, your device may be connected, and so router will forward from your input port to the correct output port, right? And the next important thing is routing. Routing is the process by which router determines what is the best path to reach the destination, right? So this is a simple architecture of a router. So router may have multiple input ports and multiple output ports, right? And routing processor. So the routing processor means it will be used to calculate the path to reach the destination. So the input port will also consist of several parts: link determination, link layer functions, forwarding table lookup. Right? So switching fabric, right? So this is the heart of the router. So it connects the input ports and the output port. So switching fabric will determine uh, how to establish the connection between the input port number. Say for example, you are connected at port number 1 and the destination device is connected at port number 4, right? The switching fabric will connect uh, using any one of these methods, right? Switching via memory, switching via bus, switching via interconnection network, right? So, uh, so switching via memory, it will copy the packet from the input port and send it to the appropriate output, right? So it will just act as a memory. It will copy the entire data from the input port to the output. Whereas switching via bus, right? We have a input port and output port, right? Uh, so it will deliver the packet, right, from the input port based on a token, right? It will assign a token so that it will transfer the data from the input port to the output port. And the third one is switching via interconnection network. We use n number of buses. Instead of using a single bus, we can use n number of buses, right? which is basically 2 power two even number of buses to connect in input ports and in output ports, right? So the output ports are transmitted out of the network. So output port is nothing but the port at which the packets are transmitted out of the router, right? And the routing processor uh, will calculate the routing protocol or it's a traditional CPU-like methodology to calculate the path to reach the destination, right? The future is a router and it will operate on layer 3, right? And it connects different networks together and sends packets and it will do the two important jobs as you know, uh, forwarding and routing, right? And there are different types of uh, routers, right? Static routers, dynamic routers, where if you are manually doing the configurations, right, and feeding the values means it will be uh, static routers, but static routers are almost obsolete now. We are not at all using static routers. So dynamic routers where routers will automatically calculate, reiterate the routing table for every 30 minutes or 1 hour, whatever, depending upon the manufacturer algorithms, right? So there are number of manufacturers, right? Who will produce the routers. Famous one is popular one is Cisco, T-Link, HP, right? 3.com, Juniper, Nortel. So next video we'll talk about further in submitting other things. Thank you.